we will often see functions that are nonlinear. So for example, profit function is typically quadratic, for the profit functions we'll see in this course at least. So quadratic functions give you this parabolic shape or upside down or right side up u. And with profits, we're often interested in maximizing profits. So how do we actually maximize a function or find the point at which profit is maximized? Well, if we take a tangent line to our profit function, you'll see at the top of the profit function where we hit the highest profit, the slope of that tangent line is 0. So in order to find a maximum for the profit, all we need to do is take a tangent line, find where the slope of the tangent line equals 0, and that will give us the quantity that maximizes profit. So knowing that we need to take some derivatives in order to maximize profit, or if we wanted to minimize cost, let's just review some of those simple derivatives and a couple rules. So first of all, if we want to take the derivative of a function y, we say the derivative of y with respect to x, and we write this as dy over dx. So a small change in x gives you a small or a large change in y. So let's cover some of these simple derivatives. So if you have just a constant, so y equals a, where a is a constant, the derivative of a constant is 0. This is because there is no x variable associated with that a. So if you change x, a doesn't change at all, so the derivative is just 0. If you have a linear function, like this one here, y equals mx plus b, the derivative of this is just m. Now if you have a polynomial function where you have an exponent on the x, the rule is we drop the exponent down to the front, multiply it with whatever constant is in the front, and decrease the exponent by 1. Let's take those derivative rules and apply them to maximizing a profit function, that profit function we just saw earlier. So if we have an equation for our profit function of pi, is the representation of profit, what we usually use, equals 4 plus 5q minus q squared, what is the maximum profit and the quantity that maximizes this profit? So let's do that example. We're trying to maximize pi, that's a function of q. So we know that if the tangent line, or the slope of the tangent line equals 0, that's our point of maximization. So that's equivalent to writing the derivative of pi, or profit, with respect to q equals 0. So we know that our profit function equals negative 4 plus 5q minus q squared. So taking the derivative of that profit function with respect to q, so the derivative of negative 4 is just 0 because it's a constant. The derivative of 5q is just 5. And the derivative of the last term will be negative 2q because we're dropping the exponent down to the front and decreasing the exponent by 1. So now all we need to do is set this derivative equal to 0 and solve for q. So solving for q gives us 2.5. So this is the q that maximizes profit. So now that we know what q is, we can actually find that maximized profit. So we're just going to plug this q star into our profit function, and that's going to give us 2.25. So one last rule that we'll cover here for derivatives is the product rule. So we want to use this rule when taking the derivative of a product of two functions. So for example, if you have the function h of x, it's the product of f of x times g of x, then the product rule tells us if we take the derivative of the first function, multiply it by the regular of the second function, and then add it to the regular of the first function plus the derivative of the second function, that will be our total derivative for h of x. So let's do an example for that one as well. So let's say h of x is 3x and x squared minus 2. So here's our first function, and here's our second function. So let's calculate the derivative of h with respect to x. So the derivative of the first function is just 3, and then I'm going to write just the regular of the second function. And I'm going to add that to the regular of the first function, and the derivative of the second function, which is just 2x. And then you can simplify this down a little bit, so I'm just going to bring the 3 inside and multiply out the last set there. And you'll end up with 9x squared minus 6x.